Hello everyone, welcome to 714 Day 2. Today we're going to be continuing our examination of the cosine function. Yesterday you guys should have built your table representing the cosine function, so today we're going to take a little bit of time and we're going to plot the points on that table to get an idea of what the shape of a cosine function looks like. And then we're going to use what we know about sine and cosine as well as the Pythagorean theorem to establish a coordinate system on the unit circle. So we'll go through a few problems that do that together, and we'll establish some cool tricks here. All right, so first we're going to start with constructing the cosine graph, and I'm going to demonstrate this on MyOpenMath. So hopefully yesterday on MyOpenMath you completed your cosine table. All right, so you should have all of your green check marks here going down the left, so you can see what it should look like there. And notice one of the big differences here between the cosine table and the sine table is that the y coordinate over here, this far right column, represents a horizontal distance rather than the height, right? So when we look at any of these cars' position, the height is the distance from where the car is down to the x-axis. And now what we're looking at is a horizontal distance, right? So if I'm here at car 4, the horizontal distance would be the distance back to the y-axis. Okay, so we're looking at this distance either to the left or to the right from the y-axis to whatever car it is we're interested in. All right, so that is the big difference. It analyzes two very different pieces of information inside of that unit circle. All right, so as far as graphing this thing goes, it's the same as any other time we've graphed any other function. We're letting the angle from car 1 represent x, and we're letting the horizontal distance from the center represent y. So we would plot these as ordered pairs just like we would any other point in a function. So this first point is at 0, 1, right? So 0 on the x-axis is located right here. 1 on the y-axis is located right here, and then I would plot my point. All right, so that would be our first point. And we'd repeat this for every subsequent point. Right, so we'd go right 15 degrees, and then we go up to 0.966 and kind of eyeball it there in between the 0.9 and the 1. Right, and then we would repeat it again for 30 degrees. So 30 degrees is going to be at 0.866. Right, and take your time, try and eyeball it as close as you can. If you are close enough and precise enough, it will give you a green check mark. If you're off a little bit, it might give you an orange check mark, which is fine. You don't have to worry about going back and fine-tuning the points or anything like that. I'm going to go through and hand grade them, so if you are somewhat close, I'm going to give you credit for it. So don't worry if you got the orange check mark, as long as you can see the shape. You'll know the shape if you got the shape right when you're done. All right, it's a pretty definitive shape. All right, so let's go to 45 and 0.707. About right there, maybe a little bit lower. It should be just above the 0.7. And then 0.5, so right here. And then 0.259. And then 0. Right. So there's all the way up through 90, right? And that's kind of what we're going to do for the rest of these points. So I'm just going to fast forward a little bit and get the rest of these points plotted. All right, guys, so you should have your graph plotted at this point. So you can kind of take a look at mine and see that shape. You see that wave forming again. And again, you have to kind of imagine if this thing continued on, you would see that same wave, right? Continue in both directions here. So we've only graphed what we would call one period or one cycle of sine going from 0 to 360. So it's like riding the screamer ride just once, and this is what you would see. Some of the big differences you might notice with sine or cosine, like if you were comparing this to sine, sine usually starts down here, right, at 0, 0, whereas cosine starts off at 0, 1. All right, so that's kind of the big definition. If you're looking at 0 degrees of rotation, cosine starts at 1, sine starts at 0. All right. Otherwise, they pretty much have the same shape. It's just like cosine has been shifted a little bit to either the left or to the right. All right, so this is your cosine graph. That's all there is to graphing it. Make sure you have this done, and when you are done, make sure you submit and see if you got You know, if you got the orange check mark, like I said, it's okay. It just means one of your points is a little bit off. I'm going to go through and manually grade them, so not a big deal. All right. Okay, so let's go back to our notes and let's talk about this idea now that we know cosine and we know sine. We actually have this ability, we have the tools to establish a coordinate system on the unit circle. Okay, so for instance, I can put any point that I want on this unit circle and I can find its coordinates. So let's say I put a point right here. Okay, and I draw the angle out to that point, and we know this angle, let's call it theta. Right, so there's theta, and you know, normally we drop a height here, which creates a 90-degree angle. And since this is a unit circle, we know the hypotenuse is going to have a length of 1. Now this point right here has a location because we have placed this unit circle on an x-axis and a y-axis, right, which is a two-axis system, right? So that means this point has an x-coordinate and a y-coordinate. Okay. X usually represents the horizontal distance, right? So it would represent this side of the triangle down here, and y usually represents the height, which would be this side of the triangle right here. And when we examined sine and cosine, we found that sine would find the height, right? So if we were writing the coordinates of this thing, we might say that instead of x and y, we could use cosine and sine, right? Because cosine found this side of the triangle, so we could say cosine theta. And instead of y, we could say sine theta. Okay. And these two things would end up being exactly the same. Cosine would be used to find x, sine would be found or used. Sine would be used to find y. Okay, so in this table, I kind of put those three things together: the horizontal distance represented by x, found using cosine; the height represented by y, found using sine. Okay, so let's give it a try. Let's see what we can do with this and use it in an actual problem. All right. So in our graph here, they show us the angle of rotation, right? So this is our angle of rotation from the start of the ride to where the rider is currently located. So this is their current location, right? And we're trying to find the coordinates of this point, right? So we would say x comma y, and we know that we can find x using cosine theta, and we can find y using sine theta. Okay. So if I'm finding coordinates, remember, we're trying to find something that looks like this, x comma y, and we can do that by using cosine theta and sine theta, or in our case, they're letting a represent the angle, so we could say cosine a and sine a. There we go. And then I would just go to my calculator and do that calculation. So let's go here, turn this on, and don't forget that our angle is in degrees here, so we want to make sure that we are in degree mode. So I'm going to hit that mode button and just check and make sure that I'm in degree mode on my TI-84, and then I'm going to do the cosine of 135 degrees. And there's our x-coordinate, and then I'm going to do the sine of 135 degrees, because that would find my y value, and there's my y value. Okay. So I'm going to go ahead and write those numbers down. So we got negative 0.707, right, because our horizontal distance here is off to the left. And when we did the sine, we got a 0.707, and that was positive because our vertical distance went up. All right, so that's really all there is to finding coordinates, right? Just remembering that we can find x using cosine, we can find y using sine, and then we just use those to establish the x and y values. Now it does want to know the measure of the reference angle, so remember the definition of a reference angle is the angle inside of the triangle in between the hypotenuse and the x-axis. So this is our reference angle right here. Now we know that going from the start of the ride halfway around here to ground level, that would be 180 total degrees. So we know the angle here on the outside is 135. So I can find the reference angle by taking 180 minus 135, and we would find that the reference angle is 45 degrees. So this would be 45 degrees inside of the triangle. That's our reference angle. Okay. So let's try another one. Right? And sometimes instead of an angle, the problem gives us only information about sine or cosine. Right? So in the scenario below, we're given information about sine. They tell us what sine is. But even though that's all we know, we can still find cosine and establish our coordinates using the Pythagorean theorem. Okay, so this point where the writer is located still has a coordinate. Okay, and since they told us what sine is, we know the y-coordinate. We know this is negative root 3 over 2. What we don't know is x, right? We need to figure out what x is to complete our coordinate. So we know this side of the triangle, since they told us sine, we know this side is negative root 3 over 2. We know the hypotenuse is always 1, and the side that we're missing here is x. Right, so this is still a right triangle. So according to the Pythagorean theorem, we can do legs squared plus legs squared equals hypotenuse squared. Okay, so if I'm looking at my diagram that I set up here, right, we know one of the legs, we know the hypotenuse. So I'm going to say, here's one of my legs, negative root 3 over 2, and I'm going to square that thing. Right, legs squared. The other leg is x, right? We don't know what that is, so I'm just going to write x squared. And then the hypotenuse is 1, so I'm going to put in 1 squared. Right, and then I just go through very carefully here. I'm going to simplify and take care of my exponents and everything. So in this first one, right, if I square everything that's in the parentheses, I don't want any decimals here because notice that it says exact coordinates. So we don't want any decimals. What we're going to do is we're going to take this negative root 3 and we square that. And then the 2 also gets squared. So when we square a fraction like this, you square the top and you square the bottom. Okay, so I'm just going to set that up. And then here 1 squared is just 1, so I can do that pretty quickly. Now let's think about what happens here. When we square a negative, we get a positive. So the negative is going to cancel. And then when we square a square root, the square root and the square cancel. So all that's going to be left here in the top is a 3. Okay, and then in the bottom I do 2 squared, which is just 4. So this is 3/4 plus x squared equals 1. Okay. So I'm going to continue this over here. To get x by itself, I'm going to subtract 3/4 from both sides. Okay. So that way the 3/4 will cancel. All that's left is x squared on the left-hand side, and then we need to think about this, 1 minus 3/4. So when we subtract with fractions, guys, I like to envision a pie, and this pie has 4 slices, and I'm taking away 3 slices. Okay, so if I have a pie with 4 slices and I take away 3 of them, all I have left is 1 slice out of 4. Right? So I know 1 whole pie minus 3/4 of the pie leaves me with 1/4 of the pie. Okay. Now I'm going to finish this off. Since this is x squared, I just need to square root both sides of this equation, and the square and the square root cancel, so all we have left is x. And when we square root a fraction, you square root the top and you square root the bottom. Right? So square root of 1 is just 1, and the square root of 4 is just 2. And guess what? We just finished our coordinate. We found out that x, and there we go. So those are the exact coordinates. And just keep in mind, when the instructions say exact, okay, this is important. Do not put any decimals in your answer, okay? They want the fraction, they want the square root. They don't want you to put that into your calculator. All right, so just leave the coordinates just like this. All right. The other thing to keep in mind is to make sure that you check your position on the unit circle. So notice that my horizontal distance here goes off to the right, so I know x has to be a positive number, which we did get. We got a positive 1 over half. And our sine is negative, right? The vertical distance is negative here because it's going down. So that means we need to make sure that there is a negative on the sine value. Okay. So you do need to check that at the end of each problem. All right, let's do one more just to make sure we got it down. So in this scenario, they tell us that the sine is negative root 2 over 2. So this is where our writer is located. And since they told us the sine, they told us this side of the triangle. They told us about the vertical distance or the height, right? And this is negative root 2 over 2. Now we know the hypotenuse is always 1. And what we don't know is the x value here, this horizontal distance of the triangle. All right, so they're going to give you some piece of the triangle. One piece you always know, that's the hypotenuse. So it always sets up a nice Pythagorean theorem that we can set up. All right, we're going to go ahead and do this here. So we've got legs squared plus legs squared equals hypotenuse squared. This is one of our legs, so I'm going to say negative root 2 over 2 squared plus x squared, that's our horizontal distance, equals our hypotenuse squared, which is just 1, so there's 1 squared. And then remember, we square the top and we square the bottom here since it's a fraction. Okay, when we square a negative, we get a positive, and when we square a square root, the square root and the square cancel, so it's just going to be a 2 up here. And then we square the bottom, so that's going to give me a 4. And then we have x squared equals 1, right? 1 squared is just 1. So we're going to keep going here. I'm going to subtract 2/4 from both sides. So very similar to the last problem that we did. Just last time we subtracted 1/4, now we're subtracting 2/4. So my pie still has 4 slices and I'm taking away 2. So that means I'm going to have 2 slices left over. All right. Then to finish this off, I'm going to take the square root of both sides. So we get x equals, and we square root the top and the bottom separately when we do something like this. All right, so the square root of 2, it doesn't simplify. It's not a nice number, so we're just going to leave it as the square root of 2. And then the square root of 4 does simplify to something nice. The square root of 4 is just 2. Okay, so if I'm writing this coordinate, okay, we already knew the height, so we knew that was negative root 2 over 2. And then we just figured out the x value to be root 2 over 2. And then I'm going to make sure that I analyze my position, right? So my x went off to the left. My horizontal distance is off to the left, so this should be a negative value. So I'm just going to go ahead and put a negative in front of it. And my y value, or my height, was also negative, so I need to make sure there's a negative there as well. And there is. So that's it. That completes our problem. That's all there is to those Pythagorean theorem problems. If you have any questions, make sure you let me know in the Zoom chat. Have a great day, guys.